All right, so good morning. This question is from the topic of current electricity. The level of the question is bit intermediate, and the kind of question this is very graphical. A figure is given, which can confuse the students. So my job is to give you detailed explanation of as to what is happening. Uh, First, read the question. I will just increase the size of the question so that you can read it carefully and take your time to. So I hope you can read the question. Just take 2 minutes to read the question first. Okay, so it's a situation of a 12-volt battery and connected in a certain manner. So this is the circuit. A circle of 4-meter radius. Okay, using a wire which has a resistance of 2 1 by 2 pi ohms per meter. Let me see if it is 1 by, okay. The pi is in the denominator. Okay, so this is not the pi. The pi is here. Okay, this is the pi we are referring to. All right. Anyway, so you know this wire is the one which is the resistor. The question is how much current is being drawn from the battery. I hope you have read the question. I will reduce the size of the question. It will give me some area to write on. Okay, so I'm just going to reduce the size of this question. You can hopefully still read it. Anyway, okay, so let's uh, get going on solving this problem. Okay, now if you see the circuit, the wire essentially is the resistance, right? So this angle is 90 degrees. Okay, so the way I look at the circuit is that the the smaller arc, okay, the smaller arc is one radius, and the bigger arc is the other radius. Okay, so the current comes in, and the current splits at A. This is the node where the current splits. So one part of the current goes here. Okay, so let the total current be I. One part of the current goes on the larger arc. The other part of the circuit goes through the smaller arc, like this. Okay, so the current splits into two parts. Now let's look at the circle. Okay, and think what is the meaning of the larger and the smaller arc. Okay, let me just redraw this. Okay, so this is the situation. Not a great circle, but that is what it is. Okay, so you have a situation like this, and the exit of the current. So the current exits here, it enters at this node. This is another node, one branch and the second branch. And this is your 90 degree. Okay, so this is your 90 degree. Now let's see. The overall radius of the circle is 4 meters. So this is 4 meters. So that means the circumference is going to be how much? This is the circumference of the wire, whose resistance per meter basis is this. If you notice the lower arc, which is AB, right? This arc, what is the resistance? Right? So the lower arc, because this angle is 90 degrees, 1/4 of the total wire length. So I have calculated the resistance of the lower arc. Okay, this is where the current splits, and now the value of the resistance which you get, okay, for the lower arc is 4, and this is 1 ohm. So this is 1 ohm. 1/4 of the wire is 1 ohm. The balance, part of the arc will be 3/4 of a circle, right? So if 1/4 is 1 ohm, then 3/4 of the arc is what? Is going to be thrice as much, right? So this is going to be equal to RAB upper part is going to be 1 by 2 pi into 3 by 4 into 8 pi. So this goes away. This is 4 is equal to 3 ohms. So we know this resistor is 1 ohm and this resistor is 3 ohm. Now, when I started discussing this question, I told you the confusion is because of the circle. Okay, if you look at the circle, how do we, what is the next step? See, you can apply Kirchhoff's current law and stuff like that, saying that we will apply a loop here and the second loop is here. No need of doing that because if you'll notice, the upper the upper arc and the lower arc are connected between the same points. The potential difference between A and B is fixed. Okay. Therefore, if I have to redraw this circuit, I can redraw the circuit as this. Okay, so I'm going to redraw this circuit. Since the two arcs are between the same potential difference, they are in parallel. Okay, that makes our life so simple now. If we find the equivalent resistance between AB, so the equivalent resistance is between AB, this becomes equal to 3 into 1 upon 3 plus 1, right? So this becomes 3/4 of an ohm. Now we know the total resistance in the circuit. So this circuit can be reduced, right? So you can redraw the circuit and say the circuit now looks like this. So this is 3 by 4 ohms and this is 12 volts. Okay. So what is the current being drawn? This is 12 divided by 3 by 4. So this is 48 divided by 3 is 16 ampere. Right. So the answer is 16 ampere. Okay. Now this particular question teaches you valuable lesson that whenever you see some odd shapes like this, right? A lot of students are accustomed to seeing a circuit like this. Okay, the resistance should be looking like a resistance, but that is not necessary. They can give you a wire of square shape, they can give you a wire of triangular shape. Okay, so let me give you another example. Though this is not part of the question, but you could get a question like this also. So let's say you are given a triangle, right? You are given a triangle like this, and this is the battery. Okay, this is the battery. Now, you can still be given the perimeter of the triangle and you can be given the per meter length resistance. What is the resistance per meter? It is given to you. The perimeter of the triangle is known to you. It's a uniform resistance throughout the length of the triangle. So if this is, for example, x, x, and x, and this is y, okay, right? So this is x meter, x meter, x meter, and assume the resistance per meter length is 1 ohm per meter, which means this will become how much? This will become x ohm, and x ohm, right? X into 1. Now, if you notice A and B, right? A and B have AB direct as a resistor of x ohms, and then these two are in series. Okay, these two are in series. X and X are in series. I hope this is making sense. Now the circuit becomes 2x and x, and this is your y. Okay. So these two are in parallel law, and you can find the equivalent resistance and calculate the value of the current being drawn from the battery. This is why volts. The point I'm trying to make is please don't get into any confusion. If you see odd shapes, it is not necessary for your examiner to give you this. They can give you any shape. You just need to focus on the distribution of the current and the shape, whether the potential difference is identical in both the cases, parallel, right? So A and B are connected between the same two wires, whether it's a circle, whether it's a triangle, whatever it is, you should be able to solve such questions with ease. I have a fantastic playlist of current electricity and circuits. Please go and watch it. Some right from the basics of drift velocity to the Ohm's law, which is studied at microscopic level, followed by equivalent resistance, followed by Kirchhoff's voltage law, current law, heating effect of current, the potentiometer, voltmeter, ammeter. Everything is given in that playlist. Go and watch it. Okay, it'll give you a lot of benefit by way of making you understand conceptually. You cannot memorize this subject. Okay, after a while you will start forgetting it. So it's better to strengthen your concept and practice conceptual questions. And last time also I told in one of my videos that please do reasoning and assertion. A reasoning and assertion forces you to think about the reasoning, which is what the concept is, right? The reasoning has to be clear. Why are we doing this? When I looked at this question, I had two streams of thoughts in my mind. One is, do I go for Kirchhoff's current law and Kirchhoff's voltage law, or can I go for a simplified lower level complexity thinking? I chose the lower level complexity thinking. If I had failed, I would have gone to the next level because the circuit initially looked very complex to me. But I had a good look at it and I realized these are two parallel circuits. Just a gimmick to convert the resistor into some sort of wire. So I hope you enjoyed this video. Please do subscribe to this if you're interested in conceptual videos. Please put your comments. Please give me suggestions. And I'm open to them so that I can prepare videos accordingly. Thank you very much again and wait for my next video.